Hello and welcome back to Genius Mathematicians. In today's video, we will be looking at some IGCSE style questions. You could pause the videos and try them out. The word solutions will be provided side by side. But before we get started, don't forget to like, share, and subscribe to my channel. And press the bell icon to get all future notifications of any videos that I post. Let's get started.
In this question, we're supposed to find the value of x. So to do that, we have to keep in mind of the rule log c a minus log c b is equal to log c a over b. We have to make sure to do this, the bases must be the same. So let's see how we could apply this in this question. We can see that these two, the first term and the second term, are in minus and that their bases are the same. So we can apply this rule. We first take log 2 as common and then we put 2x plus 1 over x. And this whole expression will equal 2. The next rule we have to keep in mind to solve this is if it's log a, b is equal to c, then b is just equal to a to the power of c. So if we apply this rule, we get 2x plus 1 over x, because that's our b in this equation, is equal to 2 to the power of 2, which is 4. So it becomes 2x plus 1 over x is equal to 4. And if we cross multiply to send the x over there, we get 2x plus 1 is equal to 4x. Now let's put all the terms of x on one side and the numbers on another. So it will be 2x minus 4x is equal to negative 1. 2x minus 4x is negative 2x, and we write negative 1 as it is. And as we can see, there's a negative sign present on both sides, so we can cancel it out. Then we get 2x is equal to 1. If we send the 2 over there, we get half as our final answer. Let's try a problem similar to this one. In this, we're supposed to find the value of x again. But now, we have a third expression on this side. Let's keep in mind the rule we learned earlier, that if two expressions with the same base are in minus, then we can represent them in another way. We can take log 2 as common and write x plus 1 over x. And that will be equal to log 2, 7. As you can see here, there's log 2 present on both sides of the equation. So we can get rid of this from both sides. That would get us x plus 1 over x is equal to 7. And now we just need to solve the equation. We send x over there first. So we get x plus 1 is equal to 7x. And then we send the 7x to the other side to get x minus 7x. And if we send the 1 to the other side as well, we get negative 1. So x minus 7x is negative 6x. And we have negative 1 here. If we remove the negative signs from both sides, we get 6x is equal to 1. But to get the value of x, we need to divide 1 by 6 to get 1/6. And that is our final value of x. In this question, we can send the 2 as a power of x, and that would get us log 3 x squared minus log 3 x minus 2, and that would equal to 2. And as we can see here, we have two expressions with the same base in minus. And if we apply the law we learned earlier, we can take log 3 as common, and then we get x squared over x minus 2, and that is equal to 2. We can write x squared, x minus 2 is equal to this number, which is 3, to the power of this number, which is 2. So we would get x squared, x minus 2 is equal to 9. If we send this there, we get x squared is equal to 9. Then x minus 2 in brackets because 9 is multiplying with both of these. We would get x squared is equal to 9x minus 18. And now, if we send all the terms here to get a quadratic equation, we would get x squared minus 9x plus 18 is equal to 0. To solve this quadratic equation, we could use the quadratic formula or we could use the middle term break method. So the coefficient of x is 1 and c is 18. So 1 times 18 is 18. And we need two factors that would get us negative 9. So two factors of 18 are 1 and 18, 2 and 9, 3 and 6. If I think of 3 and 6, that multiplies to get 18, and 3 plus 6 gets us 9. We have to put a negative sign before these two because negative 3 times negative 6 gives us 18, which is what we want because 1 times 18 is 18. But if we do negative 3, negative 6, we also get negative 9 like we wanted. So if we write it as x squared minus 3x minus 6x plus 18 is equal to 0. Negative 3x, negative 6x is still equal to negative 9x. I just wrote it in a different way. We take x common, so we get x here. X squared divided by x, we get x. And negative 3x divided by x gives us negative 3. And over here, if we take negative 6 common, we get negative 6 here. Negative 6x divided by negative 6 leaves us with x, and 18 divided by negative 6 leaves us with negative 3. And as we can see here, these two expressions are the same. So we can write it as x minus 3 and x minus 6 because of this. And that is equal to 0. To solve it now, we have x minus 3 and x minus 6 is equal to 0. So if we send this term here, so now we have x minus 3 is equal to 0. If we send the negative 3 there, it would be 0 plus 3. So the x is equal to 3. That's one answer. But another answer could be if we send the x minus 3 to the other side. And x minus 6 would equal to 0 then. And if we send the negative 6 there, it would be 0 plus 6, which is 6. So that's why we get x is equal to 6 or x is equal to 3. In this question, we have two possible answers. So in this question, we're supposed to find the value of this expression in terms of a. And it's also given that log 3x is equal to a. We have to give each answer in its simplest form. So let's get started. We can see that 9x is in multiplication because that could be 9 times x as well. And a law of log says that log c a plus log c b is equal to log c a times b. And this expression looks very similar to this expression. So if we rewrite it in this form, we would get log c, which is log 3, a, which could be 9, plus log 3, x. And if we write it in this form, we can get back to this. So there is no difference in the values, we're just rewriting it in a different way. And log 3, 9. We can notice that 9 is the power of 3. We can rewrite 9 as log 3 to the power of 2. If we send the 2 in the front, because that's another law of log, we would get 2 log 3, 3. And log 3, 3. And we also learned that log a, that means any number here is always equal to 1. So log 3, 3, 3 and 3 are equal, so we can rewrite it as 1. So it'll be 2 times 1. Now let's look at log 3x. It was given earlier in the question that log 3x is equal to a. So instead of log 3x, we can write it as a because they're the same values. And we can continue to write a here. So our answer would be 2 times 1, which is 2, plus a. This is our answer in the simplest form. Let's try a similar problem. In this question, we're supposed to find the value of this expression in terms of a in its simplest form again. And it is given that log 3x is equal to a. So let's get started. You may have noticed that if we put log C a minus log C b, that would equal to log C a over b. And this expression look very similar to each other. So if we rewrite it in this form, what would we get? So we get log 3 x to the power of 5 minus log 3 81. Because we're rewriting it like this, these two values are still equal to each other. So we can set the 5 at the beginning of the log because that's another log. So we get 5 log 3x minus log 3 81. 81 is simply 9 times 9 and 9 is simply 3 times 3. So in 81, it's 3 to the power of 4. So we can write 3 to the power of 4. But like we did in this part, we can also send the 4 at the start of log. So we get 5 log 3x minus 4 log 3. And we also learned that if the base and this are equal, then that can simply cancel out and equal to 1. So we would get 5 log 3x minus 4 times 1. And 5 log 3x, if we just look at the log 3x part, we notice that it is the same as this. So instead of writing log 3x, we can just write 5 times a minus 4 times 1, which is 4. So we get 5a minus 4 as our expression in terms of a in its simplest form. I hope now you understand log quite well. Bye bye.